Good afternoon and welcome back. My name is Ashley Pollock. I am the Business Development Manager for the Frequency and Timing Space products. We develop and manufacture space-qualified oscillators, atomic clocks, and other timing subsystems. As you can see here, we have a large variety of space-qualified oscillators available at various frequency outputs and performance levels. I'll go into a lot more detail of these, but as you can see here, there's just a quick overview of the variety that we offer. So today I'm going to talk about our new products. We have a couple new products in development, our Space CSAC and our Satellite Timing Module. Then I'm going to go into some of our heritage products, an overview of our space-qualified oscillators, as well as some of the subsystems and atomic clocks that we've delivered for space. And then I'll close with a summary of our core capabilities. So new timing products for space. We have our chip-scale atomic clock. Microsemi has developed the first radiation-tolerant chip-scale atomic clock for LEO applications. So the Space CSAC is actually derived from our commercial CSAC product, which is currently available in the market today. Similar to the commercial version, the Space CSAC main advantage here is swap and affordability. The current pricing for the Space CSAC is actually lower than most of today's high-precision space oscillators of comparable size and weight. The other advantages of the Space CSAC are not only does it provide frequency control, but also it provides timing. It has better than 10 times accuracy performance versus a crystal oscillator of 5 times higher power. It also has great holdover performance. It can provide accurate timing during a GNSS outage due to signal interruption or jamming. This also enables satellite cross-linking. By having this, it eliminates the need for the timing uplink from the ground station, which also makes you less vulnerable or not vulnerable at all for signal jamming. The links in space, the cross links, cannot be detected from ground. So next slide. So here you can see off to the side is a breakdown of the physics package inside the Space CSAC. It's a cesium MEMS gas cell. And as I mentioned before, swap, the power consumption is less than 120 milliwatts and weight less than 35 grams. The Allen deviation is 3 to the minus 10 at 1 second, so superior accuracy. I do want to make a comment here about the operating temperature. We're currently speccing it at minus 10 to plus 70 degrees C. We do have an ongoing effort with the commercial CSAC to expand the temperature range. Once that has been completed, it would be applicable to the Space CSAC. So schedule going forward. Currently, right now, we have the sample production lot in process. We hope to have them completed by the end of July. Then we'll go on with our qualification testing, which will include SEE and TID testing. And then we hope to have flight production units available by the end of October. If you'd like any additional information, my contact is there on this slide. So Satellite Timing Module. Satellite Timing Module provides autonomous and accurate local frequency and timing for individual or constellations of satellites. So essentially timing in space. Currently, frequency sources are required for timekeeping and metrology in most satellites, all satellites. Typically, these sources are crystal or quartz oscillators. In some cases, atomic clocks are required when absolute precision accuracy is required. So there is a natural drift associated with these clocks. So the frequency and time will need to be adjusted by the ground station. So By doing this, currently right now, you're susceptible to signal jamming. The satellite timing module uses a 1 PPS output from a spacecraft GPS receiver to optimally steer the oscillator using proprietary common filtering algorithms which Microsemi has developed that we call CAS2. So by doing this, you pretty much eliminate the need for the ground station. You no longer need that timing uplink, and you enable the possibility of cross-linking among satellites. The STM is a flexible design that allows for a trade-off of performance versus power and weight. If swap is an absolute driver, which it is in some applications, we could use the 9800 oscillator that you see here, the miniature oscillator, or if higher accuracy and precision is required, we would use our UltraMaster oscillator here on 9500. The design includes a power supply, a voltage-controlled OCXO, 100 megahertz PLL circuit, and the controller assembly that contains the FPGA. Our STM module actually evolved from a custom platform timing module, which we had developed and have delivered recently. So going forward, we would like to use the RTG4 in our STM module to meet performance, radiation, and flexibility goals. So the next steps for STM is we will continue on with our feasibility study using the RTG4. Once we've completed that, we'll analyze the performance data to our target specification, and we would circulate that information with our customer base and move on. If you need additional information, you can contact me. My information's on this slide. We have also written some white papers on this product that are available as well. So I'm going to give a quick overview or a brief overview of our space-qualified oscillators that we develop, our heritage products. All of these products are developed in our facility in Beverly, Mass. You can see over here, there's a nice little picture of our facility and the team that assembles and tests these products. We've delivered over 70 cesium atomic clocks and well over 800 crystal oscillators into space. We've supported multiple government programs as well as exploratory programs, GPS, SBIRS, and multiple NASA missions. We have an extensive background in quartz technology. Our oscillators are designed and used in multiple satellite applications, spaceborne GPS receivers, up-down converters, synthesizers, transponders, etc. So our strengths and in-house capabilities. Microsemi designs and manufactures 3 different variations of space-qualified oscillators. So we manufacture VCXOs, voltage-controlled oscillators, TCXOs, temperature-controlled oscillators, and OCXOs, oven-controlled oscillators. We specialize in providing precise timing and frequency solutions with customers with the most demanding performance requirements. Customers who have applications that require ultimate accuracy and precision. So in order to support this, we have to have an infrastructure in place to do so. So we have separate manufacturing capabilities focused on additional environmental controls, high reliability materials. As you can see over here in the picture, there's a photo here of our space assembly glass room. So customers that we support, we all recognize that schedule is always a very important part of the mission. So we stock standard Class S and Class B electronic components, as well as an established supply of our critical components, such as long lead items like the hybrid and multiple standard frequencies of our crystals we keep in-house. So our 96 and 9700 oscillators, These oscillators use a hybrid circuitry, which allows for the greatest possible reduction in size without compromising performance or reliability. They are offered in the two packages you see here, the D-sub connectorized package as well as the PCB mount package. They're available in frequency ranges of 1 megahertz to 25 megahertz. They all use an SC-cut quartz resonator. We've probably delivered well over 300 of these oscillators into space for multiple programs, such as CloudSat, MUOS, WorldView 3, Messenger. Both of these oscillators can be customized to various output frequencies, warm-up time, G-sensitivity, any other characteristics that would be necessary in order to meet a customer-specific performance requirement. Next, we have our 9800 oscillator. This is our ultra-high frequency oscillator. It's available in 40 to 200 megahertz. It has superior long-term stability. It again uses an SC-cut quartz resonator. The ADEV performance is around 5e to the minus 12 at 1 second for our 50 megahertz option. We have standard frequencies available for this oscillator at 50 and 100 megahertz. It also can be customized to meet customer-specific performance requirements, so you can get this in custom output frequencies as well. All the discrete components are manufactured and tested to Class S standards, and it's available in grade 1 or 2 EEE parts. Next, we have our 9960 TCXO. All of our TCXOs and VCXOs are hybrid, and they're hybrid oscillators, and manufactured at Class K qualified facility. We've developed and delivered oscillators from 10 to 100 megahertz. We have a standard 10 megahertz offering, but like our other oscillators, it can be customized to meet customer-specific performance requirements. Additionally, all of our hybrid oscillators use a vacuum-sealed versus open-blank crystals, which provides the low aging and excellent phase noise and short-term stability performance. Next, we have our 9500 ultra-stable oscillator. It has the best stability performance available in a commercial product today. So you're looking at part in 10 to the minus 13 at 100 seconds. This oscillator has been used in multiple key programs. It's currently the master reference oscillator for the GPS-3 program, as well as SBIRS High, LRO. It has capability for digital frequency control using an FPGA. It is a very environmentally rugged design. It has internal vibration and isolation systems. It's also available in grade 1 or grade 2 EEE parts. So next is an overview of some of the atomic clocks and oscillator subsystems that we've delivered in the past. You can see over here is the 4410 cesium atomic clock that was supplied for GPS Block 2F. We also have other subsystems that we've delivered, including power supplies, multiple or redundant oscillators, synthesizers, frequency multipliers, so on. So again, to recap, summarize our core capabilities, we have extensive experience with precision quartz oscillators for space applications, low noise circuit design and frequency synthesis, extensive experience with advanced timing capabilities, and atomic clock development for space. And we also have a long expertise in radiation characterization, analysis, and testing.